All right, let's talk about probability. Has it ever felt like, I don't know, a magic trick you just can't seem to follow? Well, today, we are skipping all the confusing formulas. We're going to build your intuition right from the ground up. And trust me, by the end of this, it is going to click.
So why does this stuff feel so counterintuitive so much of the time? I'm here to tell you, it's not you. You're not bad at math, you're not bad at probability, you've probably just been taught it backwards. So let's fix that right now.
And this, right here, this is the problem. Most courses, what do? They just throw formulas at you. You memorize them for the test, and then, poof, gone. We are doing the exact opposite. We're going to start with the intuition that your brain already has.
Okay, let's dive right in. There is one single misunderstanding that trips almost everyone up. But here's the thing. Once you see it, I promise the entire concept of probability just starts to make sense. Okay, this right here, this is the core idea. We tend to think probability is about a single specific result, like drawing exactly red marble number 1. But it's not. It's actually about the event, which is just the chance of drawing any red marble. See the difference? That shift from a single outcome to a whole set of outcomes, that is the secret key. Seriously, this simple little shift in focus, from individual outcomes to these groups we call events, that is what's going to rewire your brain for all of this. It is the foundation that unlocks absolutely everything else.
Okay, so let's break this down. It's super simple. Step 1, you've got your whole universe of possibilities. We call that the sample space. In this case, it's 10 unique marbles. Step 2, you define your event. The question we're asking is, what's the probability of drawing a red marble? That's our event. So, step 3, we just count. How many outcomes fit that event? Well, there are 5 different red marbles. So the event drawing red includes 5 different outcomes. And finally, step 4, the calculation. It's just the outcomes in our event divided by the total outcomes. 5 red marbles out of 10 total marbles. It's just 5 out of 10, 50%. See? No crazy formulas, just counting sets.
So if you remember one thing, let it be this. An event is just a set. It's a group of outcomes we care about. From now on, whenever you see that formula, P of E, that E should be your trigger. It just means you need to ask yourself, okay, what specific outcomes are in my set?
This works for anything. Let's try it with 2 coin flips. The sample space, all the possible things that can happen, is heads heads, heads tails, tails heads, and tails tails. 4 outcomes, right? But the question we ask is what creates the event. If we ask, what's the chance of at least one head, we'll look at the sample space. That event is the set of HH, HT, TH. 3 outcomes. What if we ask, what's the chance both coins match? That's a different event. It's the set HH, TT. Just 2 outcomes. You see how it works? The question we ask carves out a specific set from the total possibilities.
All right, so now that you're thinking of events as sets, we can start combining them. And this is where things get really, really powerful. And you'll see, it's actually pretty visual.
So let's tackle a classic problem, one that trips a lot of people up. You have a 52 card deck. What is the probability of drawing a king or a heart? Now be honest, what's the first calculation that pops into your head? Because a lot of us make the same initial mistake here.
Your gut instinct is probably just to add them up, right? I mean, it makes sense. There are 4 kings, there are 13 hearts. So you just do 4 plus 13, you get 17. So 17 out of 52 seems simple enough.
But it's wrong. And the reason is, by just adding them together like that, we've accidentally counted one very important card twice.
And this table makes it super clear why. Take a look at the King of Hearts. It's sitting in 2 categories at the exact same time. It's a king, yes, but it's also a heart. That's our overlap. That's the card we double counted, and we have to account for it.
So this brings us to what's called the addition rule, and it's pure intuition. You take the probability of A, you add the probability of B, but then you have to subtract the probability of A and B happening together, that overlap. So for us, it's 4 out of 52 plus 13 out of 52, and then we subtract that one card, the King of Hearts, that we counted twice. That gives us the real answer, 16 out of 52.
Okay, this next part, this is maybe the most powerful idea in all of probability. And it's that probability isn't static. It's not fixed. It's dynamic. It actually changes the moment we get new information.
So let's set the scene. Imagine you're about to draw one card. Right now, your entire universe of possibilities, it's the whole deck, all 52 cards.
But then something happens. Someone peeks at the card and tells you just one little piece of information. They lean over and say, "Hey, the card, it's a king."
And just like that, bam, your reality changes. Those other 48 cards that aren't kings, they just became totally irrelevant. They're gone. Your entire universe of possibilities has now shrunk down to just those 4 kings. Any probability you calculate from this point on happens inside this new, much smaller world.
And what you just did right there, that is the absolute core of what's called conditional probability. It's not some scary formula, it's just the simple, intuitive act of recalculating your chances, but inside a new, smaller universe that's been defined by the information you just got.
Okay, let's apply this whole shrinking universe idea to a really famous problem that messes with almost everyone's head, even doctors. Here's the setup. A test for a rare disease is 99% accurate. The disease only affects 1% of people. You take the test, and it comes back positive. So, what's the probability you actually have the disease? Your gut is screaming 99%, right? Well, let's see.
Let's make this real. Imagine a group of 1,000 people. Now, the disease only affects 1% of the population, so out of our 1,000 people, only 10 actually have it. And since the test is 99% accurate, we can be pretty sure those 10 people will test positive. Those are our true positives. But what about the other 990 people who are perfectly healthy? The test has a 1% error rate, right? So 1% of those 990 healthy people, that's about 10 people, are also going to test positive. And these are the false positives. Okay, so here's where it all comes together. You tested positive. That is your new information. And what does new information do? It shrinks your universe. We are no longer looking at all 1,000 people. Your new universe is just the 20 people who got a positive result. And inside that smaller universe, what do we see? 10 people who are actually sick and 10 people who are perfectly healthy. So what are your odds? You're one of those 20 people. Your chance is 10 out of 20, which is only 50%, not 99%. Pretty shocking, right?
So let's bring this all home. Look, the goal here today wasn't just to get you to memorize a few rules. It was to fundamentally change how you approach any problem that involves uncertainty.
Because at the end of the day, probability isn't just about math problems in a textbook. It is a way of thinking. It's about understanding that the questions we ask define events, which are just sets. It's knowing that new information literally shrinks the universe of what's possible. And it's realizing that sometimes our gut feeling, it's just plain wrong. So the real question I want to leave you with isn't about cards or coins or marbles. It's this. Now that you have this intuition, what uncertainty in your own life are you going to see a little differently?